All right, guys, happy Monday. In this video, we're going to talk about special right triangles. We have two different types of special right triangles. The first one we have is this 45, 45, 90 triangle. When we say 45, 45, 90, that's talking about the degrees within the triangle. Okay, so obviously we have a 90-degree right angle, and then our two other angles here are both going to be 45 degrees, right? That adds up to 180. You also know that when we have angles that are equal to each other, that means the sides across from each angle are going to be equal to each other as well. So if this were, say, 10, then you know the other one is also going to be 10, right? The type of triangle that is specifically is an isosceles triangle. When you have two sides that are the same, it's going to be isosceles. So in this case, we have an isosceles right triangle here. Okay. What makes this special is that it will always follow the same rule, where each of these are a leg, and then this is a hypotenuse, right? The hypotenuse is always across from a right angle, okay? And this hypotenuse is always going to be a square root 2 times longer than each leg, okay? So that always follows that rule in this 45, 45, 90 triangle, okay? So for example here, if we have a leg that's 3, right? The other leg, okay, these are both legs, is going to be 3 as well. The hypotenuse, remember, is always going to be a square root 2 times longer. So if this was 3, then that would be 3 square root 2. Okay? Again, we have a leg that's 9. The other leg is going to be 9 as well. The hypotenuse is going to be a square root 2 times longer. And that's always the case with our 45, 45, 90 triangles. Okay? It only gets kind of tricky here if we have a side or a leg that's square root 3. This leg is also going to be radical 3. And then remember, the hypotenuse is always a square root 2 times bigger. So it'd be like saying square root 3 times square root 2. Well, if you multiply those together, you just get square root 6, right? So shouldn't be too bad if we do it that way, okay? Also, know that sometimes it doesn't give you the leg, and instead it gives you the hypotenuse. So in this case, we have 4 square root 2 as the hypotenuse. Remember, the way it's set up is these are both x, and this is x square root 2. Well, obviously, we know that x has to be 4 then, because x is in front of the square root 2. Okay? Sometimes it's tricky, though, and it gives you a whole number. Well, what the heck is this supposed to be? Like, that's x square root 2, this is x, right? Well, what's in front of square root 2? There's no square root 2 here, okay? Well, to find what this is, you're just going to set equal to x square root 2, right? And you have to find what x is. So what we're going to do there is divide both sides by square root 2. Really, you're doing that in this other example here, right? But 4 square root 2 over square root 2, these just cancel and you're left with 4, right? So let's just do that here. If we do 8 over square root 2, well, how the heck do you divide that? This is what we call rationalizing the denominator, right? We've practiced this. Rationalize the denominator. You did this in Algebra 1. We practiced this to start the unit. Remember, rationalizing the denominator, you just multiply the top and bottom by whatever that radical is, okay? So in this case, the top just becomes 8 square root 2. The bottom is just square root of 4 now, because 2 times 2 is 4, right? Square root of 4 is just going to be 2, though. So 8 square root 2 over 2, right? And then 8 over 2 simplifies to 4 square root 2. Okay, so if you're trying to find what x is, it's going to be 4 square root 2 and 4 square root 2, right? Let's think about checking our work here. If we did 4 square root 2 times square root 2, then what you would get is 4 times square root 4, which is 4 times 2, which is 8, which is what we started with. Okay, so you're able to check your work as well, but that's what we want here, okay? You might have to divide by a radical, and we're going to do that later again, but that's the only time it gets really tricky, okay? So if you're trying to find each leg, divide it by square root 2, which ends up just being multiplied the top and bottom by that square root, okay? Cool. All right, so let's try it one more time, okay? So in this case, a leg is 7, so the other leg is obviously 7. The hypotenuse is 7 square root 2. Nothing crazy, but let's try it again here. All right, so in this case, we want to find what each of these legs are. Okay, so we're going to do 20 divide by square root 2 to find it. Okay, multiply the top and bottom by square root 2. You get 20 square root 2 over 2, right? Square root 2 times square root 2 is just 2. Okay? Again, that's square root 4. Square root 4 is 2. Okay? 20 over 2 simplifies to 10. So each leg is just 10 square root 2. Okay? Let's go ahead and take a look at our other triangle now. So this time we have a 30, 60, 90 triangle. A little bit different, right? We don't have equal sides because we don't have equal angles in this case. 30 degrees is my smallest angle, so that's going to produce my smallest leg. So this is what we call the small or short leg. Okay, 60 degrees is across from my long leg. And then our hypotenuse is across from the right angle. Okay. Our small leg is just going to be x. It's going to be just simplified or signaled by our variable x here. Okay, the hypotenuse is always going to be double whatever the small leg is. Okay, so if our small leg is 4, the hypotenuse is 8. It's just doubled, okay? Also, the long leg is just going to be square root 3 times longer than the small leg. Okay, so whatever that small leg is, you just multiply it by square root of 3, and that is what my long leg is. So let's take a look here. 6 is across from my small leg. So to find the hypotenuse, we double it, right? So the hypotenuse is going to be 12. My long leg is just going to be whatever that short leg is times square root 3. So that's what we're looking at here, okay? Short leg is 6, long leg is across from 60, and then the hypotenuse is just doubled, okay? All right, let's take a look again here. 10 is across from my short leg. So my long leg is just going to be 10 radical 3. My hypotenuse is going to be 20. It's just doubled, okay? Sometimes when it's a radical, it might be a little trickier, but you just want to do square root 2 times square root 3 again, right? We know that's obviously going to come out to square root of 6. We've done it before, right? And if we want to double what x is, then you just get 2 square root 2, okay? So that's what we're looking at here. Try not to slip up when we have a radical. We have our rules right above it, right? The hypotenuse is always 2 times longer than the small leg. The long leg is square root 3 times longer than the small leg, okay? All right, so if we have the hypotenuse is 16, how do you find the short leg? Hopefully you're saying to yourself, oh, we can just cut that in half, right? This is 2x, this is x. We'll just cut it in half to find what x is. So in this case, that's going to be 8. Remember, this is still always going to follow the same ratio here. So if this is x, then x square root 3 is going to be just 8 square root 3. Okay? So hopefully that doesn't trip you up too much. If you have the hypotenuse, you should be able to figure it out still, okay? All right, and then what if we're given the long leg? This is the trickiest one. Remember, this is x square root 3. This is x. This is 2x, right? Well, if this is x square root 3, then you obviously know x is 3, right? Because x is in front of square root 3. And then 2x would be 6. Okay? The way you solve it mathematically, again, you just divide by square root of 3. Divide by square root of 3. Those cancel, you get 3. So let's do that for this case here. We have 12, and we want to find the short leg. So to find the short leg, we want to do 12 divided by square root 3. Okay, this is what we call rationalizing the denominator again. So if we do 12 over square root 3, we're going to multiply by square root 3 over square root 3. You get 12 square root 3 over 3, because square root times square root cancels. And then we get 4 over square root 3. Okay, that's what we got for the short leg. To find the hypotenuse, you just double it. So if we do 2 times 4 square root 3, you're going to get 8 square root 3. Okay, so if some of this doesn't make sense, maybe rewind, watch it again, scroll back and see what we got, okay? Last thing I'm going to do with you is number 4 here, okay? 15 is across from 60. So this is my long leg. X is my short leg. To find that, we have to do 15 divided by square root 3, right? You got to take the square root 3 out of it, because this is going to be x square root 3. This is just x, and then this is 2x, right? 15 over square root 3 can't be divided, so you have to rationalize it. Then we got 15 square root 3 over 3, and that's going to simplify to 5 square root 3. And then when we double it to get y, you're going to get 10 square root 3. Okay? All right. This right one should be an easy one to end off on. 30 degrees going across gives you a side length of 14. Remember, we double it for the hypotenuse, so the hypotenuse is going to be 28. 60 degrees is across from our long leg, so that means we just have to do 14 square root 3 for my long leg, okay? So it always follows this setup. 30, 60, 90 always follows that setup. 45, 45, 90 always follows this setup, okay? So we'll practice this more tomorrow, and then any questions you have, let me know.